In this video, we're going to look at quadratic transformations, which means that we're going to be changing or modifying an original quadratic function. Just as a refresher, when we talk about parent function, we're talking about the original function that the graph started from. So when it comes to a parent function of a quadratic, it is always just f of x is equal to x squared. And I'm going to get my calculator and just show you what that would look like if we graphed it. So if I went over here and I were to graph a quadratic, and I typed in x squared and hit enter and graph, you can see what it looks like right here. It goes through origin, has a point at origin, and it makes kind of a upward bow shape. So I'm going to go ahead and I'm going to graph this. So second and graph gives me my points, and I have a vertex at 0, 0. And the way that I know this is the vertex is, notice if I look at my y values, I have a 1, and then I have a 0, and then I have a 1 again. So anytime you see a repeating y value, whatever that number is in the middle is going to represent its vertex if you're looking at the table. So for instance, it's 0, 0. So I'm going to go ahead and put a point at 0, 0 right here. And I'm going to label it 0, 0. And I'm going to write that is my vertex. Now another way you can find it is you could go back to the graph. You can hit second and trace, and in this case, because it opens upward, it has a minimum, and you can go to minimum, hit enter, move over to the left side of the vertex, hit enter, move over to the right side and hit enter, enter, and it'll give you the vertex. So here's our parabola on here, you can see, and what I'm going to do is actually going to use a feature in the calculator. And I'm going to hit second and trace, and since that's a minimum because it's at the bottom of the curve, that's my minimum value, I'm going to hit minimum in that menu, go to the left side, hit enter from our left bound, go to the right and hit enter from our right bound, and enter again, and notice it gives me my ordered pair to the maximum and minimum. Now that's also my vertex, 0, 0. So it's just another way that you can find the vertex. There's more than one way, but when it comes to my minimum value, it would be y equals 0. So you can just use this function to easily find the vertex if you like to. Now what we're going to do is we're going to go ahead and graph a few points. So let me go back to our table, and notice right here, right, we can see 0, 0. That's my vertex. It's also easy to see because notice that the y value repeats itself before and after the vertex. So we have a 1 and then a 0 and then a 1 again. That's also an indicator that is the vertex. So I'm going to go ahead and plot 0, 0, which I already did and I labeled it. And I'm going to go ahead and plot 1, 1. So I'm going to go over here, 1, 1. And I'm going to label it 1, 1. And then I'm going to plot 1 on the left side, negative 1, positive 1. So negative 1, positive 1. Now if you look, we can go ahead and draw a parabola from here. So I'm going to go ahead and draw that function real quick. And it's just a sketch, but that way you can see what it looks like. So the parent function always looks like this right here. So there's my parabola, right? It looks like a bow. So you can, some people say parabola, right? Remember that it looks like a bow. And now let's see what happens to it when we take the parent function of x squared and we simply put a negative sign in front of the x squared. So this is one transformation. It is going to have a reflection over the x-axis. So let me show you what that looks like. Now I'm going to go ahead and go over to my calculator. Now we already have this function. I'm going to leave it in there so you can see that it's just going to flip down when we put that negative sign. So I'm going to go here and I'm going to type below it in y2 negative x squared. I'll hit graph. There's my blue function, and watch this new one, the red one. Notice it just flips down. It looks like it mirrors down, and we call that a reflection. So I'm going to go ahead and I'm going to graph that. Now I'm going to clear this out just to prevent any confusion. I'm going to clear the first one, go back, and I'm going to hit second and table. And notice here we have a point at negative 1, negative 1. So I'm going to go to origin, go to the left 1 and down 1. Put a point right there, right, negative 1, negative 1. We're also going to have the same vertex. It's going to be 0, 0. And then we're going to have a point at 1, negative 1. So 1 and down 1. So the next transformation I want to show you is what happens when we change the a value in the quadratic by making it either greater than 1 or less than 1. And I'm just going to give you an example. I'm going to write one over here. I'm going to say f of x, because on the left we're going to make it greater than 1, is equal to, and when I say the a value, notice we've been dealing with x squared, and the a value is the number that's in front of x. And in examples I showed previously, we were using a parent function, right? And so there was just a 1 in front of this x. In other words, I just had x squared. And I'll just graph it and show you, right? So that's x squared, that's our parent function. But let's say we change that number in front of x. Let's say, since we want a number greater than 1, let's say that I put a 2 in there. So instead of f of x equals x squared, we're going to have f of x equals 2x squared. And let's see what happens. So I'm going to go over here. I'm going to leave this original so you can see how it changes. I'm going to go over here, and under my second function, I'm going to go ahead and put 2x squared. And then I'll graph it. And I want you to notice that it looks like it is now more narrow, right? It got a little skinnier. We call that narrow, right? It means that it basically was like this and it kind of pulled in a little bit. And we also call this a vertical stretch. So anytime you have a number greater than 1 inside for that a value, in other words, in front of x, anything greater than 1, it's going to have a vertical stretch and pull in towards the y-axis. So let's go ahead and we're going to plot this on a graph. So I'm going to go ahead and go to my table. Notice it shows two different graphs. The first set of y values is for my first graph, the parent function, and the second that says y2 is the second graph, the new one that is more narrow. So notice our y value is different. So while the x remains the same, our y values change. So I'm going to go ahead and I'm going to graph this. So the original, I'm going to graph the original first. We was at 0, 0. I'm going to graph that one in pink. So 0, 0, and that was the vertex. And then we had one at negative 1, 1. So negative 1, positive 1. And we had a point at 1, 1. So this is how our graph used to look. And then we modified it, right? We went ahead and we put a 2 in front of the x. And so for the modified version, notice it's still at 0, 0. So I'm going to do that one in black. I'm just going to circle origin because it's still 0, 0. But what changed was our y values, right? So now we have negative 1, positive 2. So over 1 and then up 2. 1, 2. And then we had positive 1 and positive 2. So over 1, up 2. Oh, you know what? I put that point just a little too high. So I want you to notice that when we're looking at this, our graph just got a little skinnier. And now it's on the inside of the original graph. So let's see what happens when we use a number that's less than 1. Okay, so I'm going to go ahead and write one that's less than 1. So let's do f of x is equal to, and let's use 1/2. So 1 over 2x squared. So I'm going to show you what that looks like in the calculator. So let's go back over here. Now I'm going to erase the 2x squared. Well, we're going to leave the parent function so you can see the difference in it. And I'm going to go ahead and do alpha y equals to get my fraction bar. And I'll do 1 over 2. And I'll put x squared. And I'm going to graph it. So you can see there's our original. And now here's the new graph. And if you look, you can see it's much wider. So we call that a widening of the graph. We also call that a shrink or a compression. And so I'm going to go ahead and graph it. And I'm going to write that in a different color. I'm going to use orange for that one. So if I look at this, I got -1 and 1/2. But notice I'm still at origin. So in other words, we're still going from the origin. The only thing that changed, our vertex is the same. The only thing that changed is that we're only going half a value. So I'm going to go ahead and I'm going to go over to -1. And then I'm going to go 1/2, which is going to be about right there. And then for the point after the origin, that first one is 1 and 1/2. So I'm going to go over 1 and 1/2. So our graph is going to look more like this. So you can see right here, I'm just going to box this one in orange and draw an arrow. It becomes wide, right? And it's a shrink. On the other hand, whenever we multiply by a number that's greater than 2, we have a vertical stretch. It becomes more narrow. And it actually sits inside of the original. Let me go ahead and highlight that in black as well, because that's our black graph. Now let's go ahead and look at our last thing that we can do to it. Our last transformation is going to be a horizontal shift, which means it's either going to move left or right. Once again, we're going to start with our parent function so that we can see how it's moving. So for instance, notice over here I got f of x is equal to x plus 2 squared. But notice instead of adding the 2 after the x squared, I added inside of the parentheses before the squaring occurs. This is going to cause a shift that's either left or right, depending on if it's positive or negative. So let's go ahead and put it in so we can see the differences. So I got x plus 2 squared. So notice instead of saying x squared, it's x plus 2, close parenthesis, squared. I'm going to graph it. There's the original that goes through origin. And you can see the new one has shifted to the left 2 units. So I'm going to go ahead and draw my original in pink. I'm not going to label it this time. I'm just going to go ahead and draw it very quickly. So we were right here. That was the original. I'm now at, for my vertex, at -2 and 0. So I'm going to move over 1, 2, and I'm going to put a point there. And then if I put my point before it, that's at -3 and +1. So -3 and +1. And then the other point is at -1 and +1. So -1 and +1. So it's going to go through this part right here. So my new graph now looks like this. So you can see it shifted to the left. Put me in arrow 2 times whenever we said x plus 2 in parentheses. Now, on the other hand, let's say we do x minus 3 and square it and see what happens. So I'm going to go back. I'm going to change this plus 2 to a minus 3, and I'm going to graph it. You can clearly see the original in blue, and now when the new one's drawn, it's going to be 3 units to the right. So I'll do that one in orange. So I'm going to go ahead, pull up my table. Now once again, right, we're looking for the vertex, and I simply find it because I can see a number repeating. So we have this 1 and 1. The 0 in the middle, that's my vertex. So it's 3 and 0. So I'm going to move over 1, 2, 3. And then if I plot my points, this is how it looks. So now you can see that whenever we add something to x and square it, that our graph moves to the left, and when we subtract something from x and square it, it moves to the right. So I'm going to go ahead and box it real quick. My arrow, I'm going to put moves right. And over here, moves left. And that's everything you need to know about transformations and quadratics.